Hello, my name is Jerry Phillips. I am the developer of an app on the App Store named SwiftSize, used for sizing heating and air conditioning equipment for residential homes. I'm going to go ahead and demo the app, and the home we're going to go look at needs a new furnace for the main floor. They've got two furnaces in the home. The main floor furnace serves the basement and main floor, and we're going to go ahead and run the load for the main floor and determine what size equipment we need. The existing air conditioner is a 4-ton. It's rather old, but he wants to wait and replace that at a later date. Okay, so unfortunately I can't get too far zoomed out on this house because it is surrounded by foliage, and I can't step back far enough to get a good picture of it. But the garage here is at the end of the house, and I'm just going to kind of walk around the house, and I do all my loads from the outside of the house. I've been doing it long enough to where I can do it from the outside. This right here is part of the garage, and then right there is where it turns to conditioned space. And so we're going to go through, and I'm going to film that, and I'm going to try to pause the film in post and see if I can put some dimensions on there so that we can run the loads. I'm standing on the, by the way, I'm standing on the west side of the house. That's important when it comes to heat load calculations, and we'll go through and we'll just film everything that I'm going to be putting dimensions to later. Here's a basement window. I'm going to step back here and just film everything we're gonna be putting a tape measure to later on. And I'll just do a walk around the house. Everything has got a basement underneath it. There's no crawl space. And that upper floor is handled off of a different system, so we won't have to worry about that. Let me see if I can step back and get this entire wall length here all the way down to the end. I'm going to go back really quick over here because we did miss a window. There's a window right there in the basement. Looks like a pretty good size one. The grate over it. As you can see, everything's fully below grade. Okay, I'm going to go around this tree here. Maybe we can step back far enough to where we can get all that side there for dimension purposes. Well, maybe not, but anyways. So I'm just going to further walk around the house here. Now we're on the east side of the house. You get down over here, there's a couple windows. There's one right there. And there's one right there. This video is not any intention to teach you how to do or teach how to do heat load calculations, but how to use my software that performs heat load calculations. I highly recommend, if you haven't had a course on heat load calculations, that you take one. This is more just how to use the application. So this is a garage door here, so it's not in conditioned space, and that window is in conditioned space. So let me just see if I can get a better angle of this side of the house. Anyways, so it's going to be a little difficult to show dimension on this side of the house, but hopefully hopefully we'll get enough information to where it makes sense. Anyways, we've made a trip all the way around. Doesn't really make much sense to go around that side, as that's just the garage again, and we're back to where we began. We can pretty much take this dimension on this side of the house, and it's going to be the same dimension as the back side of the house, but we're back where we began. So I'll go ahead and pause this and we'll edit it and put dimensions on it. I'm on the west side, but this slider's facing north. So I'm going to go to the north glass. I'm going to go 6 times 7, hit the plus button. And then measuring the frame wall length on that side, the exposed wall, it's 8 feet. So I go down here to frame wall length, and I hit 8 plus. Okay, then on the west side, it doesn't matter where I start. I could do the wall or I could do the windows. I'm going to do the windows. So I'm going to east to west glass. I've got 3 2-foot by 3-foot windows with a 1.5 foot round transom above. I'm just going to simplify it and say that it's 1 foot by 1.5 foot by 2 feet. Let me double check that measurement. Sorry, these are 3 foot by 4. 3 foot by 4 foot. Sorry, that's what I meant. So 3 foot by 4 foot windows are all the same size, and then a 1.5 foot transom above, round transom. So I'm going to overestimate it just a little bit. So I'm going to say three windows times 3 feet times 5.5 feet each, and hit the plus button. And in one fell swoop, I get all 3 windows. Okay, now there's a basement window below. It's a 6 foot by 4 foot. So I'll go to basement glass. 4 times 6, and hit the plus button. Now this particular wall length is going to be 17 feet. So I'm going to hit 17 and hit the plus button. And then it jogs back in towards the house another 10 feet. So I'm going to say 10 foot plus. And I've got to get the, there's a ceiling above it. There's a exposed roof above it. It's got an attic space. So I'm going to go down here to ceiling area. And I'm going to say 10 by 17 plus. Okay. Now we're standing in front of the entryway. And I need to just quickly measure across the entryway here. And we'll call it 19 feet. So I'll go down here to, or go up to frame wall length, tap on that, and hit 17 plus. Okay, and then we have a door, a large door, and it's going to be 4 foot by 8 feet, 4 times 8 plus. And then alongside the door we have 2 windows. They are going to be 1 foot by 8 feet each. So I'm going to do 8 times 2 to get the windows. And then above the door we have a 5 foot wide by 7 foot tall transom above the door glass. So I'm going to say 7 times 5, backspace, 5 plus. Okay. Now the house jogs out again. And it should be 10 feet, which it is 10 feet. So I'm going to go down here to frame wall length, 10 plus. And then once again, we're standing on the west side in front of the pretty much this mirrored side of the house. It's a mirrored image of the other side, so it's going to have the exact same glass as the other side. So I'm going to say 3 times 5.5 times 3 of them for the glass. And then the length is going to be 17 feet. So 17 plus. And then I got to go down to ceiling area, and I'm going to say 10 by 17 plus to add that ceiling area that is above that area. And then we have a basement window area, or basement window along that same side. It's going to be 4 by 6. So 4 times 6 plus. Okay, now we're on the south side of the home, and I'm just going to quickly measure the length of the south side. Now I've already included, well actually, no I haven't. Okay, so the length of the frame wall length of the entire south side is 44 feet. So I'm going to go down here to frame wall length, and I'm going to hit 44 feet. Now the garage side, I could just duplicate the 44, but I'd be 10 feet too far for the other side, because my 44 feet includes a jog out in the house that doesn't exist on the other side. So the other side is going to be 34 plus for the frame wall length. Whoops, I'm on the wrong side. Zero, enter. Let's go back up to frame wall length. Okay, 44 plus, and we're going to do 34 plus for the other side of the house. And then I'm going to get my windows on the south side. So we have a south glass, the very far west, south facing west side window is going to be a 4 by 8. So 4 times 8 plus, fairly good size window. The next one is going to be a 5 by 8. So 5 times 8 plus. And the next one will be a 4 by 6. So 4 times 6 plus. And then I want to make sure I get any basement glass that exists on this side. And we have exactly one, actually looks like 2 basement window areas, or basement windows. We have a 4 by 6. So go down here to basement window. Four times 6 plus. And then we have another one kind of hidden away. And it's also 4 by 6. Also 4 by 6. 4 times 6. Oops, backspace. 4 times 6 plus. Okay, now I'm walking around to the east side. So I'm on the southeast corner, looking at a 7 foot, by 4 foot window on the east side. 7 times 4 plus. And then I've got a 3 by 4, or 4 foot wide by 3 foot tall. 4 times 3 in the kitchen. Okay, then I've got a little bay window area. Now, before I go to that, I'm going to go down to, I missed a couple of basement windows on the same side. And it looks like they are both 4 by 6s. So go down to here to basement glass, 4 times 6 times 2 of them. Okay, back up to, now we've got a bay window, and it faces rather southeast, so I'm going to go to the southeast side, and it is a 3 foot by 6 foot, 3 times 6 plus. And then there's one going to be on the other side, same size. So I'll go over here to northeast glass and 3 times 6 plus. And then we have 3 identical windows here. And they're going to be 2 foot by 1 6 foot. 2 times 6 times 3 of them. And then there's a window. It's also a 4 by 6. Looks like they're all going to be 4 by 6. 4 times 6 plus. Then we have a glass door, patio door. It's 3 by 7. So 3 times 7 plus. And then we have a little 1.5 by 2 foot window. Yeah, facing east, so 1.5 times 2 plus. Okay. Now we need to get a measurement of this side of the house. 21 and 27. Okay, so we got 21 and 27. That's 48. So I'm going to go down to frame wall length and just go 48 plus. And that should be the entire perimeter, it's 171 feet. Okay, now frame wall height is going to be a 9-foot height. And the basement mirrors the main floor. Except for maybe the kick out, but we won't worry about that. Not the kick out, the bay window in the back. So I'm going to say 171 feet. And the feet below grade is going to be, it is actually fully below grade on all sides. 8 foot and 8 foot height. No vaulted ceiling area, no open floor area. That would be an area above a garage. No enclosed crawl space. The floor area is going to be 34 times 48. And then the 2 kickouts, which are both 170 each, so 170 times 2. So 1972 is going to be the basement floor area. Number of people, I'm going to put, I just know how many occupants are here, but I'm going to just put 4 people. There is 1 kitchen. The ducts are all located in conditioned space, so I won't worry about the duct gain and duct loss percentage. Okay, now I need to go to more, and I'm going to just open a calculator real quick and estimate roughly what my volume of this space is. Now, I'm not going to include the upper level. If I wanted to be exactly accurate, the right way to do it is basically to include the upper floor and all the window area of the upper floor, but we're going to treat this as if, because the windows are there's the same proportion of windows on the upper level as there is the main level. So we're going to treat this as if we were just doing one level and that's all there was. So I'm going to say 1972 times 9. Oops. 1972 times 9 equals about 17,000 or 18,000. We'll say 18,000 feet. 18,000 feet. And I'm going to put a 0 in here so that when I go back, you'll see that it recalculates it. All right, now to go to, I pull down on the screen to get rid of the keyboard. I'm going to go into my design conditions. On the summer TD, 20 degrees is the typical design conditions. Winter TD, we're up at the top of Bountiful, and I can tell you from living up here that we're about 5 degrees colder than Salt Lake City. So whereas Salt Lake City is a 65 degree design temperature difference, up here I'm going to put it at 70. The doors are going to be solid wood. The basement wall is going to be at least an R11. It's probably an R13, but I don't have that option. Attic ceiling is going to be an R38. There's no vaults, so I don't need to worry about that. No crawl space, I don't need to worry about that. Excuse me, I'll go back up to here to wall. It's going to be an R13. It is a 2x4 construction, and it was built in the late 80s, and so should be at about an R13. No crawl space, no open floor area. Don't worry about grains of moisture. Don't have to worry about that because we're in Utah. We don't have to remove any grains of moisture to get down to 50%. We have to add moisture to get up to 50%. Slab on grade, no slab on grade. Footprint, I'm going to say it's 15 to 2100 square feet. Envelope is definitely best. It's got vapor barrier. No fireplaces, at least none that they're all direct vent, so don't have to worry about those. Okay, glass is going to be double pane. Okay, that should take care of everything. Now I hit the results pane, and it gives me all my totals. So, according to this, I'm going to put my sensible heat ratio just a little bit higher, 0.75. And our altitude, I'm going to put 5,000. Okay. So, according to this, I need a 410 AC, and I need a 60,000 BTU furnace. Okay, just a couple things of note on this heat load. So we have a requirement of a 60,000 BTU furnace. You'll notice that you can put the altitude in and the efficiency of the appliance you're going to install, and it will give you the input requirement of the furnace. So we need a 60,000 BTU furnace. Also, and I've got the sensible heat ratio equation upside down. I never noticed that before. But the sensible heat ratio is the sensible divided by the total. And so I figured about a 75 degree or 75% sensible heat ratio, which should be able to be accomplished with a 5-ton evaporator coil using a 4-ton air conditioner. Okay, going back to the takeoff screen, I wanted to just comment on the infiltration parameters, which is accessed when you tap this More button up in the top right-hand corner. You're presented with a dialog that asks you for the total door and window area and the total above grade volume. Now, the application will automatically calculate your total door and window area if you have a number in there that is lower than the total door and window area that you have taken off. So, for example, if you have 0 in there, and then in your takeoff you have something greater than 0, it'll use your takeoff, the sum of your glass, as the total door and window area. But if, for example, you have 1,000 square feet in there of total door and window area, and your takeoff only adds up to 500 square feet, it will not replace the total door and window area figure in there. And the reason for that is that it assumes that you are doing some room of the home or some section of the home, and you want to still use the 1,000 square foot of total door and window area that the entire structure has. This dialog, or these numbers are required for proper distributing of infiltration. So a home, for example, will have so many air changes in an hour of outside air to inside air, but it needs to know how to distribute that on a room-by-room basis. How do you determine how much is leaking into any particular room? Well, the way the load calculation does that is by the percentage of window and door area of that room versus the entire home. So, and another note on the volume of the home, you only calculate the above grade volume of the home. In other words, if you've got, like the home we just did, 2,000 square feet of that home is entirely below grade. It is not exposed to the same conditions that the above grade portion of the home is exposed. So when you're calculating the total volume of the home to figure out the infiltration rate, you don't take into account the volume that is below grade. So that's why when we did our calculation, it's essentially 19 or 20,000 square feet times 9 feet, which gives you 18,000 cubic feet. Okay, so I went back through and after scrubbing the video, found that I did make a few mistakes, minor, but thought I'd leave them in just so that you could see that you've got to be careful. And I do try to go through my loads a couple times to make sure I don't make too big of mistakes. Windows are very important. I did make a mistake on one of the windows in the bay window, but it shouldn't change my furnace size. I did have to jump from a 60,000 BTU to an 80,000 BTU because I needed the bigger drive for the existing air conditioner. Anyways, hopefully this video has been helpful. One other thing I did want to point out, I didn't know if I brought it up in the when you're choosing your floor area in the design conditions, that is a footprint. That's an aerial footprint of the house. So the amount of area that the home covers, but not necessarily all the levels added together. So you'll notice in this example, I chose 15 to 2,100 square feet because the main floor essentially covers an area of 1,972 square feet. So that has to do with infiltration. The bigger and more expansive the house, the fewer air changes per hour that the house has, and therefore it's important to pick the right footprint. So anyways, hopefully this has been helpful, and if I get another chance, I'll try to do another one. Thank you very much. Bye-bye.